Hello everyone, myself Hans. Today we are going to solve the problem of UPSC 2014 problem from topic vector calculus. Question is given, evaluate by Stokes theorems. Integral is given by where C is the curve given by x square plus y square plus z square minus of 2ax and minus of 2ay is equal to 0, and the plane is given by x plus of y is equal to 2a. Starting from 2a, 0, 0 and going below the z plane. Let's solve the problem. UPSC asked in 2014 for 20 marks. We have to use this problem to solve using Stokes theorems. First we have to know Stokes theorems. Stokes theorems is given by, this is given by closed integral C f dot dr vector is equal to double integral surface double integral. This is given by curl of f vector dot n ds. We have to use Stokes theorems to evaluate the given problem. Here f is given by, f vector is given by y dx plus of z dy plus of x dz, and we have to write first in the form of f dot dr. We know that dr vector is given by dx I cap plus of dy j cap plus of dz k cap, and we have to write this is f dot dr vector is equal to, we have to write this is y I cap plus of z j cap plus of x k cap into, here we have to write this is dx I cap plus of dy j cap plus of dz k cap, and when we have to multiply we get the above result. This is f, and from here we can also write this is, we can also write once again we have to multiplying, this is given by, once again we have to write multiplying with dx I cap plus of y j cap. We can also write this is y I cap plus of z j cap plus of x k cap dot into dr. This is dr vector. Dr vector is given by dx I cap plus dy j cap plus of dz k cap, and we have to use the Stokes theorem to evaluate. This is f dot dr. Further we have to solve. Here given square equation is x square plus of y square plus of z square minus of 2ax minus of 2ay is equal to 0, and from the given sphere we have to find the center of the sphere is given by, on comparing x square plus y, general equation of a sphere, this is x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d is equal to 0. We get the center, this is a comma 0. This is the center, and we have to find the radius of sphere. Radius of sphere is given by under root of, we have to write this is a square plus of a square, we get 0 square is get 0 square, and from here this is under root of 2a square, and from here we get this is a root 2. This is the sphere of the given this is the radius of the sphere. And further in the given question said, here x plus y is equal to 2a is the plane. First we have to find the curl of f. So we have to find first curl of f. is given by I cap into j cap k cap. This is, we have to write here del upon del x, del upon del y, and del upon del z, and we have to put here, this is the comparing f. This is f is given by here y, z, and x, and we have to find curl. This is given by, when taking I cap, this is del z del. Once again, when taking I cap, this and this parts is to remove, and we have to solving for this. This is given by del y upon del x. This is given by 0, and minus of del z upon differentiating with respect to z. This is given by 1, and minus of j, when taking operation with minus, taking j, when this row and this, once again this is column, this column and this row is removed when we have to take operation between these I and k. So we have to write here del upon del x differentiating with respect to x, this gives 1, minus of del upon del z differentiating with respect to z with y, this gives 0, plus of k cap. When taking k cap, this column and this row is removed, we have to taking operation between I and j. So we have to write here del upon del x differentiating with respect to z, this gives 0, and this is 0, minus of del upon del y differentiating with respect to y with y, this gives 1. And from here we have to, the curl of f is given by, curl of f is, this is minus of I cap, here is minus of j cap, and here is minus of k cap, and we can take a common minus from here. This is given by I plus j cap plus of k cap. This is the value of curl, and we have to further, we have to calculate once again. We have to write once again, we have to rub this portion, and we have to write here the value of curl is, curl of f is given by here, this is minus of I cap plus of j cap plus of k cap, and further we have to find here, this is given by unit normal of n cap, and we know that the given plane here, we have to find normal to the plane, normal to the plane x plus of y is equal to 2a, and this is given by, normal to the plane is given by divergence of x plus of y. Divergence of x plus of y is given by, this is, when differentiating, divergence represent, this is divergence represent, once again we have to write here, this is written as del upon del x I cap plus of del upon del y j cap plus of del upon del z k cap. Similarly we have to here, when differentiating, this gives, differentiating del upon del x with respect to x, this gives I cap, and differentiating y with respect to y, this gives j cap. And further we have to find unit normal. Unit normal is given by, unit normal is given by, this is represented by n cap, and this is given by n vector upon mod of n vector, and we have to find, this is n vector is here, this is I cap plus of j cap upon coefficient, when finding mod of n vector, the coefficient of n is squaring, this gives, coefficient of I is 1 square 1 and j is also 1, this gives I plus j cap upon root 2. This is the unit normal, and further we have to put in the Stokes theorems once again f dot dr. Here f dot dr we have to calculate, this is given by we can also write in the form of this is, we have to evaluate this integral, so we have to write in place of f dot dr, this is written as close integral c, this is y dx plus of z dy plus of x dz is equal to, here double integral surface, this is given by, we have to find first curl of f is, we have to calculate it, this is given by minus of I cap plus of j cap plus of k cap, and unit normal, this is dot product of unit normal, we have to calculate it here, this is given by I cap plus of j cap upon root 2, and here is ds. We have to solve, this is given by, once again, this is surface integral s, and when we have to take a dot product with this gives minus of 1, I multiply with I, this is a minus of, once again, minus is taking outside, and this is 1 plus of 1, 1 plus of 1, and k multiply with, here is, we can assume this is 0, plus of 0 k cap, this is 1 plus of 1 and upon root 2 and ds, and this is given by close integral, here surface integral s, this is 2 upon root 2 and ds, and ds represent here the sphere of, radius of circle, and radius of, once again, area of circle, and area of circle is given by, once again, we have to write, we have to rough this portion, and area of circle is given by, this is pi r square, and here we have to calculate radius of sphere is equal to radius of circle, because here is the great circle is great circle is the sphere, so we have to put in place of radius, here this is given by pi, and radius square root, here is a root 2a, this is written as 2a square, and so we have to write here 2 pi a square is the area of circle, and area of circle is here represented by ds, so we have to write here close integral c and y dx plus z dy plus of x dz. We have to calculate these values, and further we have to write here, this is close integral c and y dx plus of z dy plus of x dz is equal to, here we have to remove here, once again, when we have to take operation and putting the value, here we have to remove the integral, surface integral, we have to put 2 upon root 2, once again, here is minus is already present, so we have to write here minus is also, so minus 2 upon root 2, and the value of ds is given by 2 pi a square, we have to write here 2 pi a square, and from here we can also write, this is root 2 is in denominator of 2, we can also similarly write, this is minus of 4 pi a square upon root 2, and we can also, this is the final solution of the given problem, and we can also further solve 2, once again, we can also write, this is close integral c y dx plus of z dy plus of x dz is equal to, here we have to write, here 2 is written as, once again, this is minus of root 2 into root 2, and here is 2 pi a square upon root 2, and root 2 to root 2 is cancelled out, and the remaining is minus of 2 root 2 pi a square. We can also write in the form of, this is close integral y dx plus of z dy plus of x dz. This is the final solution in another form. We have to further modify. We can also stop here, and further we can also remove denominator of root 2 to multiplying root 2 into root 2 is 2 and 2 2s are 4. This is the required solution of the given problem. UPSC asks in 2014 for 20 marks based on Stokes theorems. Thank you class and thank you for watching.